Welcome. In this session, we are going to understand union find data structure in C++. Union find data structure are also known as search find, merge find, disjoint sets. Let's proceed to little introduction to these disjoint set. And as far as the Wikipedia page is concerned, you can see that union find data structure is a data structure that keep track of a set of elements partitioned into a number of disjoint subset. It supports two operations, and first is find, second is union. Using find, you can determine which subset a particular element is in. Using union, you can join two subsets into a single subset. At the very bottom at the right hand side, we can see that we have 8 singletons, and now these singletons are grouped into 3 subsets, in which the first subset is 1, 2, 5, 6, 8, second is 3, 4, and third is 7. We are going to write practical code, and before that we are going to understand union data structure, union find disjoint set using our website visualco.net. First of all, I would like to get started with initialization of the elements. Let's say I would like to initialize 10 elements. As soon as we initialize 10 elements, you can see that we have 10 elements displayed. These 10 elements are considered as 10 individual subsets which has been created. Rank of every individual element at the moment is 0, and every individual set size at the moment is 1. So we have this following information available. Now what next we can do, let's say we can find set available in this disjoint set structure. We can make use of a function find set, and let's say I would like to find something like 5. Let's say if we search for 5, you can see that we are going to get the index of that element, and we are going to return that index value. In case if the index is not returned, we are going to return false statement or something. Let's say if the element is not available, I would like to get something like 11. If we go, we can see that this element is not available in the union find data structure. Once the element has been found, we can check whether the subset is same or not, and we can perform union set as well. First of all, I would like to perform union set, in which I want to connect, let's say 1 and 2, and in order to do that, I'm going to provide I as 1 and let's say 3 as j. Once we proceed to this, you can see that sets will be identified for I and j, and in case if the set is not same, then we are going to proceed with connectivity of the elements, and we are going to increase the rank. So now at this moment you can see that our 3 node has rank 1. So this subset has rank 1. It has 2 number of elements, that means set size is 2, and total number of sets available in this union find data structure at the moment is 8, or say 9. So now what next we can do is, let's say I would like to connect more. Let's say I would like to connect 3 with 5 or something. Once we have connected 3 with 5, both the elements have been identified, and now you can see that the element has been added. Since 3 has greater rank than 5, then 5 has been added as a child node for this element. Now what next we want to do, let's say if we want to check if the set is same. Let's say if I want to check whether 1 and 5 belongs to same subset or not. So once we do that, we are going to get a boolean response that yes, 1 and 5 are available within the same subset. So hence we get that yes, both are available. And in case if the elements are not same, let's say we want to check 3 and 0, and if we proceed OK, and in this case 3 is somewhere else, 0 is somewhere else, and at the moment both of them are not available in the same subset. So this is how our union find data set work, and we are going to write code in order to write functions so that we can create union find data structures and we can perform mathematical analysis on it. To do that, we are going to get started with a new project in C++. Let's say the name of the project will be our union find data set. Let's say we are going to create this application. We're going to click finish. We're creating a sample C++ application. Let's say we're going to change a little properties here. Let's say we don't want to receive any of the command line arguments, and this is our main method. Now what next we like to do? We like to make use of a few libraries like IOStream so that we can make use of input output stream functions. Then we like to include vector because we are going to create a few vectors to maintain rank, set size and element list. Then we are going to make use of a few more libraries like stdio for standard input output. So these things will be taken. We will be using cout, so let's just remove the CStudio, that's not required. Now what next we want to do, we like to create a class known as union find, and this union find will be the data structure which we are creating in our own application. So let's say we are going to create a new class, and let's say I'm going to call this class as union find. Once the class has been created, we have to terminate that with execution operator. So once we are done with this, we have created a new class union find. Within this class, we are going to create some public and private variables. Let's say I would like to keep my vector rank size, set size as private, and I would like to make my functions which I would like to use, like one, I would like to create a constructor, then I would like to create methods like find set, is same set and union set. So what next we like to do, we're going to create a few variables here at the moment. So first of all, we like to create a few integer vectors, and the first vector will be my p list. This p list will be my union find data structure in which all the elements will be stored. Let's say we are going to take another vector, and this vector will be my set size. And one more we like to take the rank as well. So there will be three vectors which we have created here, and we like to include vectors at the moment. So let's say, since we had the vector here, the vector should be v, somewhat like this. We're going to include #include vector. We like to use the namespace std, which will allow us to use vector and all other individual sections which we are using. Now once we have this, we like to have another element that will be an integer which will define number of sets which are available. So this number of sets will display as value of individual disjoint sets available within our union find data structure. What next we like to do, now we'll get started with some constructor and functions which we want to create in our union find class. Basically, as far as Wikipedia is concerned, we have already seen that there are few methods like find set, is same set and union set. These are important functions which has to be available within our union find data structure. So now, first of all, we are going to create a constructor to construct union find data structure. To do that, first of all, we are going to create the function with the name union find, and this union find is going to receive some integer elements. Let's say we want to create n number of elements within our union find data structure. Once we have taken n elements, now we like to initialize some of the properties like element, set size, rank, number of sets and so on. So let's say the first thing which I would like to define is the rank elements, or let's say the set size elements. So first of all, we'll have n number of data sets and size of every set will be 1. So let's say we like to make use of this vector set size, and we like to make use of the function assign. On this assign, we're going to create n sets will be created and size of every individual set will be 1. This is because at the moment, let's say if we initialize that again, and let's say I want to initialize 10 elements. So 10 elements will be initialized and the set size for every individual set will be 1 at the moment. Okay, so now we have got this. What next we like to do, we like to set the number of sets created. So the number of sets created will be n. We have 10 sets created here. Once the 10 sets have been created, we like to set the rank of every element. So let's say I would like to set rank and I would like to assign some values, and for every individual element at the moment I would like to set rank as 0. By default, rank of every set is 0, and we like to assign a list as well. So let's say at the moment, once we have created a vector with n elements, it will be having 0 at all the places, and as soon as we proceed further, we are going to assign values into this P. So now in order to do that, now what I would like to do, I would like to assign values from 0 to n, and for this we would like to create a for loop. Within this for loop, we are going to get started with, let's say, 0, and I is smaller than n, and I will be plus plus, until and unless we'll reach to nth element. We are going to add in values to our P element. So let's say we like to set something like this, that P of I will be I. So values will be inserted into our union find data structure. So this is how our union find data structure will be created. And once our union find data structure has been created, now what next we like to do, we like to write some methods. So some of the important functions are find set. So let's say we are going to create find set first. So in order to get find set, we are going to write the function find set, and within this find set we are going to specify the element which we want to find. Let's say once we execute find set, you can see that we have to specify an element which we want to find, and let's say I'm searching for 5 in the data set. So as soon as we click on go, 5 element will be identified. As soon as the 5th element is identified, so in order to find that, we are going to write a simple function. We are going to return the value, and let's say we like to return the value, and we are going to write a conditional statement here. Let's say we'll say if P of I is equal to the value of I provided, let's say, so if this is true, so we are going to return I, or else we are going to return the vector find set of I. So that will be, we are going to return the value of, let's say I would like to return the value of P of I is equal to find set of I. So we are going to return values in this format. So once we are done with this, return statement will define whether the item has been found in the list or not, and later we are going to test that. So let's say we are going to return the values if one has been is available within this or not. So let's say let's execute this statement first. So now what we like to do, let's say we like to create union find. Let's say we have created UF, and we like to specify, let's say I would like to create 10 elements, and once 10 elements have been created, I would like to find my set. So let's say we like to print the cout statement, find set 5 is, so we like to print the result, and in order to print the result, we are going to execute the function uf dot our find set function, and this find set function will receive the value of, let's say, 5, and later we are going to print end L, and let's say we like to get the character so that application doesn't close. So we have the sample function here. Now we like to test this application, and later we are going to create more functions like is same set and union set. To test, you can proceed to run your application on local debugger, and now you can see that we have got the result, that find set result 5 is 5. That means we have the element available and the element has been identified. In case if this element is not available in the set, let's say I would like to search for something like 11, and I would like to run this application, I would like to build, and once we execute that, we should get some garbage. We're waiting for the result to execute. And once we have got the result executed here, you can see that we have got nothing in return because the value has not been found in the element list. The symbol list is under loading at the moment. Now, once the items have been found within the set, we can proceed to write multiple other functions, and these other functions will be like is same set, and the next function will be union set. So now we like to take a demo for these as well. Let's say in case if you want to perform is same set, and you have to specify whether 3 and 8 are in the same set or not. Let's say we have searched for 3, we have find the element 8, we check if x is equal to y. If x is not equal to y, we'll get false. If they are true, we'll get true. So at the moment the result is false because both belongs to different subset. But in case if we like to perform, we like to put 3 and 8 into one single subset, and let's say we like to click on go. Once we execute that, 3 will be identified, 8 will be identified, rank will be checked. If the rank is same, then y element will be at the top, will be the root element, and x element will be the bottom. In case if rank of x subset was greater than rank of y subset, then rank of root element of x subset will be at the top and root element of y subset will be at the bottom. So now you can see that since 8 and 3 are in one subset now, and if we define same subset, so we'll check if 8 and 3 belongs to the same subset or not. So you can see that 3 and 8 both have been identified, and since both have been identified, we can see that yes, they both belong to same subset. So now what next we like to do, we like to write these functions in our C++ code. So in order to check that for is same set, we like to create the function and we like to create an integer value or a boolean value. Let's say we like to return a boolean result, and we like to write the method as is same set, and this is same set is going to receive two integers. The first integer will be I, second integer will be j. And now what we like to do, we like to return the statement, and within this return statement we like to check whether our this element, we are going to check find set of I. If it is equal to find set of j, so we are going to get the result. If I is equal to j, then true or false value will be returned. So now what next we like to do, so here we like to say the element of 5 will be identified. Then we like to check C out whether, let's say we like to check whether 2 and 3 are in same subset. So let's say we like to test that, and we like to use our class UF. We have to use scope resolution. Then we like to use our function is same set, which takes in two values I and j. So I would like to specify I as 2 and j as 3, and whatever the result value will be displayed onto the character string, and we like to proceed end L. And we have already told you that you can use the bool flag in order to convert the values into boolean, so you can refer to previous session as well. So at this moment numerical values will be displayed. So now let's say we like to run this, and once we build this application, now once the application is tested, you can see that 2 and 3 are not in same subset, hence 0 has been defined, because at the moment you can see that 2 and 3 which have been created were not in the same subset. So let's say if I go again, if I initialize that, and if I check if 2 and 3 belongs to same subset or not, so you can see that 2 and 3 are in different subsets, hence false has been returned. Now what next we want to do, we like to perform union operation here, which is one of the important operation of this union find data structure. And in order to do that, we like to create this function, let's say union set, and this union set is going to receive two subsets. First subset will be I, second subset will be integer j. And once we have got these subsets available, first of all we have to merge subsets which are not same. So first of all we like to check if the subset is not same, only then we are going to proceed. So we'll check if not is same set. If I and j are not in same subset, only then we are going to perform this operation. So once this operation will be performed, we are going to decrease the number of sets, because you can see that as soon as two element sets are done as union, let's say we like to add 7 and 4 at the moment. So once we do 7 and 4, 7 and 4 will be connected, and one total number of subsets will decrease by 1. So once it is done, we are going to decrease number of sets to minus minus, because at the top we have already set that number of sets will be n. So we have reduced the size of number of subsets. Now we like to check if the rank of x is greater than y, then we are going to put y as a child element of x. and in case if rank of y is greater than rank of x, then we are going to put x as child element of y. So in order to do that, we are going to write another if else statement, and this if else statement is going to check whether, now we like to do it somewhat like this, we like to check if rank of x is greater than rank of y, then we like to put p of y, that means the element x will be at this position, and we are going to increase the size. So now what next we have, let's say we have rank, we like to check whether we have taken the same variable rank or not. So we have the rank element available. So here we have I and j, let's say. So for x and y, we need to find the sets first. So first of all, we are going to find the set for x, and this will be our find set I. I will be put into x element, then we are going to take y element, we are going to find the set j, and once both these elements are identified, we are going to put them in x and y. So rank of x and y has been identified. As soon as the rank is identified, now we are going to change the size of this. So let's say we like to change the size using our set size function, and we like to change the set size of x, and we are going to increase it to the set size, and the set size will be, we are going to assign that, or you can also use put or something. So let's say we like to put it somewhat like this, set size of x will be set size of y, and x will be put like x is equal to x plus y in this case. And if x is smaller than y, then what will be done, then we are going to change the element of x, and we are going to put in y here, and we like to change the set size of our yth element plus is equal to set size of the x. So here in this case, x will be added as child element of y, and if rank of x is greater than y subset, then x will be treated as the root subset and y subset will be treated as the child. So now here, once we are done this, we are going to check one more thing. If rank of x and y is equal to, if rank of x is equal to rank of y, then we are going to improve the rank of y by 1. So let's say we like to put the rank of y to plus. So by one element, rank will be improved as well. So this is like our union set function, and once union will be performed, we like to check the same subset definition. And once we are done with this, we are going to perform a few functions, like we are going to find the count of the element. So first of all, we like to number of union find data sets. So we can do that somewhat like this. We are going to get num disjoint set, let's call it as a function. So here we are going to return the number of subsets which we have taken, and once we have got this information, we can proceed to identification of the set size as well. Find set size, and in order to get the set size, so we can get set size, and we are going to specify the integer element, let's say I, and as soon as we have specified that, we are going to return the subset of this element. So we are going to return, and in order to return that, we are going to return the element p of I having the number of subsets. We are going to get the set size, and once the set size, we are going to find the set, and within this find set, we are going to get the set size element using this, that's the vector, and find set will be the ith subset which we want to find. And once this value has been identified, we are going to return that value as an integer. So now once it is done, we are going to execute some more parameters. So at the moment we have checked whether 2 and 3 will be this, and we are going to perform union set operation now. So uf dot we are going to perform the union set operation of 2 and 3, 2 comma 3, and once it is done, we again want to check whether they belong to same subset or not. And once we have checked whether they belong to same subset or not, we are going to get number of disjoint sets. So we are going to get number of disjoint sets, and this disjoint sets will be computed using our class UF, and then we have number of disjoint set function here, and we are going to end line, and later we are going to get the count size of the set. So we like to get set size for 2 is, let's say we like to get the set size for this, so UF dot, we are going to make use of the function get set size, and within this we are going to specify value is 2, and the value once it is returned we are going to use end line. So we have written our codes here. We are going to save this code, we are going to run this application, we like to build this application. Once the application runs, we are going to identify the number of elements. So at the moment we have encountered some exception. Let's just modify the exception at the moment. Let's break. Once we did break, you can see that we have got some issues at the size parameters. So in order to do that, we'll proceed to our C++ code, and we are going to check that where we have got that issue. So here what we have is, we have specified the set of statements, you have performed union statements, and then when we are configuring that same set belongs to 2 and 3 are in the same set or not, so we'll just cross check our same subset function. Here on the same set function you can see that we are finding the set, and in order to find the set, once we are providing that value here, we have to check whether this condition is true or not. If this condition is true, then I element will be returned. Otherwise we are going to find the set of the element within P. So we have to get the element from our P element list provided by the index value. So if that element is returned and it equals to P of I element, then the set has been found, because here we are finding the element, not the index. So once the element has been identified, we are going to check whether I and J belongs to same or not, and now we are going to test this application. So here you can see that now we have worked out on this function. So we are going to stop this, we are going to save the code, we are going to run this application. Once we execute that, we are going to build that. Once the application gets built, and now you can see that we have identified all the sets. So now find set 5 is 5, 2 and 3 are in the same subset, that's false. But after union set has been done, you can see that 2 and 3 are in same subset now. Number of disjoint sets is 9. Earlier it was 10, but now it is 9. And now we have set size for 2 is 2. And you can see that since we have element 2 and 3 within the one subset, hence the size has been increased to 2. So this is how our union find data structures work, and these are very important in writing applications for partitioning, and whenever we are going to write applications for finding minimum spanning tree in the graph, we are going to make use of union find data structures. I hope you understand the concept of union find data structures, and later to understand more such good examples, I would like to take you to some quick links which are available at Hacker Earth website, and there are various other available at various universities. So I would like to quickly give you some reference links. You can quickly search for union find and you can get file type PDF, and you're going to get some useful information on the website, like there are some links at Princeton University, union find. You can get these elements, you can understand the concepts a little better. Moreover, there are a few links which I have used as well in order to understand union find, and there were some examples by Julia, who has been working on this union find. So you can search for Julia union find and some of the problem sets which she has taken. So it was in juliashincoding.blogspot.com for union find and something like this. So you can proceed to this and you can understand some basic information about how union find actually works. So these are some of the good resources which can be referred. Union find algorithms can be understood using this PDF file. You can simply download that and understand. So here are few quick links. On this web page you are going to get access to a TXT file. As soon as the page opens, you are going to get this text file here. You can click on it and you can view the text content of the file and you can proceed to learning. Now here what we have is there are multiple examples for this family of disjoint available, and once you'll understand the basics of how union find and how disjoint works, you can have a simple implementation of how disjoint can be safely implemented. And here is the basic class which has been coined in front of you, which contains your constructor union find, how to find the elements and how to create union. But later with real-time examples, rank-based union is always preferred, which is the second solution, which we have done in our example, wherein we have taken this structures, we have created a constructor, then we have found out the element, wherein we have returned the element of pi if it is not found or the rank is not equal to this, and later you can perform union and you can understand the rank and you can return the elements and you can improve the rank of your x and y subset. So this is how it's a real example, and you can proceed to various other discussions related to union find on this article here. And basically finding is always done using path compression. So here is a result how path compression is used. So I hope you understand the concept of union find data structures. Thank you for watching.